Founding Fathers of the Atom. Our first founding father is Democritus. Democritus was a Greek philosopher that lived around 400 BC. He asked, could matter be divided into smaller and smaller pieces forever, or is there a limit to the number of times a piece of matter can be divided? For example, if you kept cutting a piece of cake in half, eventually you wouldn't be able to cut it anymore. This smallest piece of matter would be indivisible. He named it atomos, meaning not to be cut. He also thought that atoms were small, hard particles and all made of the same material, but different shapes and sizes. While these were all very valid theories for the time, he performed no scientific experiments to prove his theory. Our next founding father is John Dalton. John Dalton was an English chemistry teacher that lived in the early 1800s. He said that all matter is composed of indivisible, indestructible atoms. He also said that atoms of the same element are exactly alike, and atoms of different elements are different, like gold and silver. Atoms of the same element could not be different. Dalton said that compounds, on the other hand, were formed by the joining of atoms of two or more elements, and the chemical reactions involved the rearrangement of atoms. His model of the atom was basically just a sphere. Dalton's theory became one of the foundations of modern chemistry. Next is J.J. Thomson. J.J. Thomson used a cathode ray to test many metals, and they all produced the same kind of beam. Since the beams attracted towards positive, he concluded that the beams must be negative. All of the beams had the same charge-to-mass ratio, regardless of the metal used. He concluded that all atoms have this particle in common. The beams also moved a little paddle wheel, and he concluded that the beam has kinetic energy and is made of particles that have mass. He called these particles electrons, and found that they were 2,000 times lighter than a hydrogen atom, and negatively charged. His model of the atom is known as the plum pudding model, which consists of a positive blob filled with negatively charged electrons. Democritus said that atoms were different shapes. Dalton said that atoms were solid spheres, like billiard balls. And Thomson said that atoms were positive blobs filled with negatively charged electrons. Ernest Rutherford. Rutherford performed the gold foil and alpha particle experiment. He shot alpha particles at a piece of gold foil and expected most of them to go through, and most did. But occasionally an alpha particle bounced off sideways, and this confused him. He concluded that atoms were mostly empty space, but had a tiny, very densely concentrated point of positive charge. He called this the nucleus. The density of a nucleus is 2.3 times 10 to the 17th kilograms per cubic meter. James Chadwick. Chadwick discovered the neutron in 1932, which was the last subatomic particle to be discovered. Niels Bohr. Bohr viewed various gases through a spectroscope. To his surprise, they looked something like this. We now call these lines the emission line spectrum, which is caused by the emission and absorption of electrons jumping from one orbit to another. Erwin Schrödinger. He said that electrons acted as waves. He also said that electron orbits do not exist, but rather orbitals, which are 3D regions in space where an electron is likely to be.